Good morning, friends. Welcome to goonlinetrainings.com. Today, we're going to be starting with roadmap to Azure Data Engineering. So, especially, I'm going to be covering in this module Azure Data Bricks. Okay, so Azure Data Factory and Azure Data Bricks and Azure Synapses. These three will be part of Azure Data Engineering course. You can learn any course anytime, right? But only thing is that you need to have SQL and Python is the prerequisite for this course. And Azure Databricks completely coding. You have to know Python and SQL will be essential to understand Azure Databricks. Next 30 days, I'm going to be talking about completely Databricks. So if you have any questions, one-to-one questions that you are not able to answer, ask here, you can call me on this number directly. This is my office direct number. So you can call me and ask me the questions. So roadmap to data engineer. So it will be 60 days syllabus. Prerequisite you have to have SQL and Python. So any graduate, any IT, non-IT people, long gap career, long gap in careers, these people can get into data analytics or data engineering. So data analytics, low coding and no coding. Data engineering will have somewhat medium level coding, not heavy coding, because you have to know SQL and Python, right? So SQL and Python is needed. So SQL, Python, when you know, you will be able to complete Azure Data Factory, Azure Data Bricks. I'm going to be starting this module today. So after learning Databricks, you can also learn Azure Data Factory, or you can learn Azure Data Factory first, and you can learn Databricks later, or you can learn this first, you can learn later. But the prerequisite is that you need to know SQL and Python. Python, we have a full stack Python course is available. I don't recommend full stack Python course. It will be 6 months and completely web development course. Data science people, data engineering people need not learn full stack Python course. You need to learn basics of Python. Minimum 1 or 2 months course. When you know, you will be able to write very beautiful coding either in data science or in the data engineering. Python only 45 days course is sufficient. Don't go for the 6 months full stack Python. SQL, you need to know at least 45 days of SQL knowledge also. You have to have it so that you will be able to start with the Azure Data Bricks or Data Factory. From today, I'm going to be talking about Azure Data Bricks. Azure Databricks compulsorily SQL knowledge you need to know, and Python is also you have to know. If you don't know SQL and Python, ask my team to give SQL and Python videos. Daily you need to watch one SQL video, write the notes. Daily you watch one Python video, write the notes. Python is by one more trainer. SQL will be me only. By me only. SQL videos will be my videos, but Python I'm not teaching. You will be able to get one more trainers, videos. Compulsorily basics, at least 30-40 days Python classes are important, guys. Chalo. So from today, we are going to be talking about Azure Data Bricks. What is the purpose of Azure Data Bricks, and what is the Big Data Hadoop? What is a Spark, Scala, PySpark, Spark SQL, Data Lakehouse, DevOps, CI/CD, continuous in integration and continuous deployment. All these things I'm going to be covering, and Azure Key Vault as part of Databricks I'm going to be covering. These are the high level topics I'm going to be covering next 30 days or 30 hours. Clear? Once Azure Databricks got over, you can enroll for Azure Data Factory, right? Azure Data Factory is completely no coding. It is no coding. It is completely ETL software. Okay. But Azure Data Bricks is a completely coding software. We are going to be using Java coding, Python coding, or Scala coding, or any other coding you can write. But we are strongly recommending Python coding here, and it is completely big data software. The purpose of Azure Data Bricks is completely to store big data. Big data means what? It is a petabyte, zettabyte, yottabyte of data, and it is a structured data, unstructured data, semi-structured data, right? When you have the data, two things we need to understand. Step number one, you should know how to store data and you should know how to process the data. So we are now talking about not small amount of data. We are going to be only talking about big amount of data. That too, large amount of structured, unstructured, semi-structured data. Clear? So Azure Data Bricks is going to be completely big data software, and that we're going to be using. We are going to be working with the you know data bricks only for to make use of your big data architecture, right? Azure Data Factory is completely ETL or ELT software extracting the data, loading the data, storing the data. So if you know only SQL, you will be able to work with the Azure Data Factory, but you should know SQL and you should know Python as well in order to work with your Azure Data Bricks. Clear? So let us talk about what is Azure Data Bricks, why we need to use all these things we have to understand. So Azure Databricks demo, prerequisite SQL knowledge, basic Python language, you should know what is a cloud. Why cloud is important that you have to know. So if you know why cloud is important means I need not explain that. And the next one, what is the big data and what is Apache Spark and what is Apache Hadoop and what is ADF and what is ADB. I'm going to be discussing all these things in this demo today. Now, what is the course content that we are going to be planning to learn? What and why Databricks, cluster creation, Databricks file system mount points, supported languages in Databricks notebooks, utilities, file system notebook widgets, Key Vault, Azure backed and Databricks backed, multiple ways to access storage accounts, SaaS service principal, Azure Key Vault. What is a Delta Lake? Very, very important topic. Delta Lake, reading data from the different file formats, writing the data to different file formats, Spark functions, a lot of functions we're going to be discussing more than 2 weeks, aggregation, string, math, date, a lot of functions we need to understand in order to work with the data bricks, jobs creation and scheduling, and how do you deploy your jobs and everything, and how do you perform GitHub integration. So CI/CD, it is completely code storage and real-time project with ADF and Databricks I'm going to be giving, so that you will be able to work with this project and keep the project as part of your CV. Right? So we are going to be understanding purely Databricks, or that is a big data software. Right? That is the purpose of ADB. Let me give you the introduction about ADB. Right? So we know why cloud is needed. That is what I told you already. Why cloud? Okay, so before cloud, we had what is called on premises, right? On premises means what? On prem, or people will say on premises. Now we need to understand why cloud, or what is the cloud. On premises means your own hardware and software setup. So instead of maintaining your own hardware, your own software, what normally people are going to be doing today, people are going to be maintaining a rental hardware and softwares. Okay, rental hardware you will be able to get it, and rental software you will be able to get it on premises, or on prem means there's a completely own hardware and own software, right? So own hardware you need to buy it, and own software you need to buy it. The simple example I have quoted: if you wanted to buy a own car, right? Large amount of cash you need to have, and every day you need to clean the car. Insurance you need to buy. If you don't know driving, you need to have the driver, and every month salary you need to have. Once in a week, you need to fuel the car with petrol or the diesel. So you need to maintain the car, right? Everything you need to maintain, it is a big risk. If there is an accident, means if you're safe, means remaining, maintenance work or the denting work you need to take care of, and so that car will be ready. So risk will be yours. Large amount of cash you need to have it, and the driver salary, cleaning up the car, fueling the car, everything you need to take care. So that is what is called, maintaining your own car. Instead of that, what normally we do, we go to Uber or Ola. We are going to be getting a rental car. What is advantage? You need not, buy the car. You need not clean the car. You need not pay driver's salary. You need not buy, fuel. You need not buy insurance. Nothing is required. But what is the advantage? It is a rental car, pay as you go. Whatever the usage that has been done, whatever be the use, you're using it. So based on the use, you're going to be making the payment. It will be cheap or inexpensive. So what is a cloud? What is the cloud? Or cloud means online based. So Uber, Ola are giving you online services. You will be able to book a cab and use it. So cloud means online, or cloud means rental platforms today. Clear? However, you're going to buy the going to be getting the car in the rental. The same way companies are earlier using a lot of own hardwares and software. Think about ICICI Bank or State Bank of India buying thousands of hardware machines, bigger machines, buying a lot of Java software, SQL software, .NET software, SAP software, and installing and configuring and maintaining will be big headache. Instead of that, now today we have a Amazon Web Services company is going to be giving you rental hardware and software. You need not buy the software, right? So you need not buy the hardware today. You can take it for rental. Amazon is one company. Azure means Microsoft company is also giving you, and one more company called Google Cloud Platform, GCP from Google. You will be able to get so the rental hardware and software from these companies, so that you can go, get thousands of machines with SAP installed, Java installed, SQL installed, Oracle installed, Android installed, may based on the usage. It will be cheaper. So today I need 1,000 machines. Tomorrow I need not have 1,000 machines. I wanted to have only 500 machines. You can easily say, hey Amazon, I don't need tomorrow 500 machines. It will be very, very easy, right? But if you're buying 1,000 machines today and no business is coming down, you need only 500 machines. You cannot, sell those hardwares, or you cannot, sell the softwares you bought already. Scaling up, scaling, down will be very, very difficult, right? So what is on premises? On premises means maintaining my own hardware and software. And what is cloud means today? Cloud means rental platforms. Cloud means online, but rental platform. Who's going to be giving you rentals, hardware and software? Amazon companies created AWS, Amazon Web Services. So you can go get 1,000 machines for rental. Whatever be the software you ask them, they will be able to configure and give it to you. You can store your data, you can store your applications, you can store everything. Storing the data, processing the data can be done in the rental platforms, which are cheaper. And you don't maintain a risk free. Amazon company will be maintaining, Azure means Microsoft company will be maintaining, and Google, GCP means Google Cloud Platform, Google company will be maintaining. It is cheaper, 24 by 7 high availability, scale up and scale down. I need 1,000 machines today, you can get it. I need tomorrow only 200 machines, you can scale down, right? Increase, decrease number of machines. That will be easy, risk free, high availability. Because of this, many companies started using cloud. Cloud means what? Rental platforms today. Rental hardware and software. In the hardware and software, what you do? You're going to be storing the data, and using application, you're going to be processing the data. End of the day, two things we're going to be doing in a computers, right? So any computer, maybe your own computer, doing two things. One is called storing the data. Second one is called, with the help of an application, we are going to be processing the data. So end of the day, own system, or it may be your rental system, doesn't matter. We are going to be doing only two things, but these are very very cheap. When you go in for a Uber cab, Ola cab, how much you're going to be paying? Only 300 rupees or 400 rupees based on the usage. So always rental platforms are cheaper. Why cloud has become so popular today? Only one reason: it is very cheaper when you compare with the own servers, maintaining own servers. That is the reason. Okay. Now, as we know, end of the day, IT industry is going to be dealing with a large amount of data that we know. So IT industry stands for the information technology. Information, if you want to get it, so how do you get the information? By using the data, right? Information can be derived information technology is IT industry, right? If you want to get the data, we are going to be storing the data. Step number one, you need to store the data. Second one is called, you need to process the data. Two things IT industry is going to be doing. One is storing a data, and IT industry is going to be doing the second one is called processing data. Already we discussed many times, right? So when you have a small amount of data, IT industry is going to be storing them into files, right? So we know IT industry is going to be doing only two activities. One is called storing data. Okay. Then it is going to be computing or processing data. Storing data means if it is small amount of data, where do you store? Processing means I'm talking about processing data again. Processing means doing some kind of an operations on the data. For example, I would like to store small amount of data. Small means I'm talking about KBs of data or megabyte of data, MBs of data. I may be using a file like Excel file, PDF file, or maybe CSV file, or any file. The data can be stored. We're talking about small size data here, right? Now, if the data size is medium level data, I'm getting GBs of data every month. Think about Amazon company, State Bank of India. Every month we are going to be getting medium size of data. Medium size means GBs of data. So that data IT industry is going to be storing in SQL, RDBMS, right? So structured query language we are going to be using, and with the help of the language we're going to be creating a databases, and we are going to be storing the data, retrieving the data. SQL is backbone for large amount of structured data, but end of the day the data will not be there in only GBs. Think about Amazon company is getting every month 500 GB of data into 12 months data. It will become 6000 GB of data, right? 6000 GB, when you turn into terabytes, it will become 6 terabytes per year. But at 10 years of data, I'm talking about. So within 10 years, it will become 60 terabytes of data. Maybe 100 terabytes of data I would like to store, right? So this much of a data, if you wanted to store, as we know, we cannot use SQL. We have to go in for data warehousing system when the data size is in terabytes. The companies are going to be using data warehousing data. Now here I'm going to be talking about large size data, right? Now this was a story. Now you need to understand this kind of a data is also called as a small data. Okay, companies are calling this kind of data is also small data. So when you have a small size data, KB, MBs of data, we can use Excel sheets or the files. When the data size is GBs, we can go in for SQL or database management systems. When the data size is in terabytes, we're talking about data warehousing data. All this data, small data, and all this data is called a structured data. Structured data means what? Only the data which is there in rows and columns, right? You create a table, you store the data, sales ID, product ID, sales amount, blah, blah, blah. Employee data, employee ID, employee name, employee salary, employee gender, employee date of birth. So structured data means the data which is available in rows and columns. So this was a story till 2000, right? People are happy, people were able to get the data, and slowly you're going to be working with the data. 1960s, the C language came in. the files are created. 1970s, you got SQL is released into the market to store the data. Data warehousing is released 1999, 90s. Okay, 1990 data warehousing is released. So all the things are able to capture the data. People are happy. But after year 2000, what has happened? After year 2000, three things have been taken place. One is called internet became so cheaper because of that social media completely introduced, and the hardware also became so cheaper. Year 2000 onwards, two things have happened. One is called hardware become cheaper, internet is introduced all over the world, and you have a lot of sensors data, especially social media. Because of these three things, year 2000 onwards, the data is started with the big volumes. So that is the big issue. The Google company first analyzed it. Google company identified, now what will be the data that we are getting, because everybody started using Google that time. Google is became so popular. People are talking about lot of things, and Google realized we are getting not only structured data, we are getting unstructured data, semi-structured data, this data, that data, and it is not a small data. They have given a special name to that. They said it is a big data. Now it is a big data. Who realized this? It is realized by Google company. When it is a Excel data or double Excel data or triple Excel data, unlimited data. So this has happened in year 2003. By which company? A company called Google. Google realized that now we are getting so much of a data in the world. Now, earlier the IT industry was completely focusing on structured data, and very slowly. So 1960s to 70s, 10 years gap. 70s to 1990, 20 years of gap here. So that means they don't have that much of a data. So they don't have that much of a data. 10 years there is no R&D. After that they have realized we need to have a sophisticated systems to store the data. IBM company actually invented SQL. This company called IBM company invented SQL in 1970s. After 20 years, there was a complete gap, 80s and 90s. Again, people are seeing a large amount of data, and to store large amount of data, they need to invent one more technology, that is data warehouse. Clear? So data warehouse means it is a bigger hardware, but software wise, SQL software will be installed there. So hardware wise, bigger, but software wise, SQL is to be installed. I'll talk about data warehousing later. But somehow they were talking about data warehouse 1999. So they're able to capture terabytes of data. That was fine. But year 2000 onwards, the problem is started. We are getting so much of a data. The special name to the data is given. It is petabyte of data. It is not a small data we're talking about. It is petabyte data, zettabyte data. It is Excel data, double Excel, triple Excel, yottabyte of data. This kind of a data, how do I store? So there is a software called Hadoop is introduced. Okay, in year 2003. Okay, 2005 I think 5 3. They have implemented Google. Google has implemented a big data terminology, and they have created a framework for the big data. If you have this much of a data, how to store and how to retrieve? In 2005, there is a organization called Apache Software Foundation organization, done R&D with the Google, and they have released a software called Hadoop, Apache Hadoop in 2005. This is what is called big data Hadoop software. Now Hadoop has a lot of issues, and immediately you got one more software called Apache Spark. If you wanted to store a large amount of data, Apache software company has released one more software in year 2009, okay, into the market. Now today we have either Apache Hadoop or big data Hadoop and big data Spark. These are the softwares that we have today to store and process large amount of data. So you need to do two things, storing and processing, right? So Who's going to be storing petabyte, zettabyte, yottabyte, yottabyte of data? Maybe structured data, maybe unstructured data, maybe semi-structured data. Now, earlier we were only able to store structured data. Big data means not only structured data. Big data means what? It is a structured, it is a semi-structured, it is unstructured data. Unstructured data is also called as a binary data, zeros and ones. Your audio files, video files, blah 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 is a binary data. Unstructured data means binary data. Binary means photos, audios, videos, images, all the data. Semi-structured means XML files, JSON files. Structured means rows and columns data. Clear? Like that, we have different types of data that can be stored in the big data Hadoop software or Apache Spark software. Today, earlier, we do not have any system to store, right? And analyze this kind of a structured, unstructured, semi-structured data. Earlier, we had only structured data, but today, Hadoop is, identified few problems and given solutions. What is the first problem it has identified? So we can have any kind of a data. So that means volume could be anything, variety and velocity. Three V's the big data Hadoop is given a solution for. What is that? Any kind of a data you can store. That is a variety of data. That is step number one. Structured, unstructured, semi-structured data, either Apache Hadoop or Apache Spark can be used. Apache Spark and Apache Hadoop, these two are free softwares. You need not pay not even single rupee for anybody, but you need to buy hardware. Right? Hardware you need to buy. Software Apache Spark is free. Apache Hadoop is free. Hadoop is already gone. Apache Spark, we are going to be using it. So Apache Spark is what kind of a software? Which is a big data software. It's going to be giving you three benefits. One is called any variety of data it can store. That means it can store structured, unstructured, semi-structured data. That is one thing. Step number two, it can have any volume of data. Volume means petabyte, zettabyte, blah, blah, blah. You don't store small amount of data. It will be very risky and big slow. So when you have a large amount of data, the better go in for Apache Spark or Hadoop. So small amount of data means the better go in for your SQL or Teradata, data warehousing or files. So, but don't go for the smaller databases. So small size data means never use your Apache Spark or Hadoop. Second problem it has given solution, that is any kind of a volume of data. It can unlimited data. That's it. Any type of data, variety of data it can deal with. Second problem it is having any volume of data. Third one, the volume can come in which very big speed. That is the problem. For example, I'm getting every month 1 lakh, 1 lakh, 1 lakh like that. So or 1 million, 1 million I'm getting every month, or every hour I'm getting 1 million data. So whether slowly it is coming or every minute or every hour I'm getting 1 million rows. So the speed in which velocity means the speed in which data comes. Data, 1 month data may be 1 million rows, or 1 minute data may be 1 million data. Whether it is 1 month or 1 minute doesn't matter. Any velocity, any speed in which the data comes, it doesn't mind. I can accommodate the data into big data Hadoop or big data Apache Spark. Yeah, am I clear? So these three problems Apache Spark is identified. So the Google has done the first R&D on this data. Now we have IT industry is using only four, either files or SQL or data warehousing called small data. Big data means we have Apache Hadoop or Apache Spark, and Excel is a paid software, right? SQL is a paid software. Data warehousing is also built using SQL. It is also paid software. Apache Spark or Apache Hadoop is completely free. Who has released this software? Apache Software Foundation. Clear? So this is what you got to understand. So now what is the data bricks? Data bricks is going to be a big data software only, Apache Spark only. Clear? So if you wanted to store large amount of data, as we know, we have Excel or the files. Right? Excel we may use, or the files we may use, any file. Or SQL we may be using it, or data warehousing we may be using it, right? But today I'm talking about a bigger data, means I'm talking about either Hadoop or I can use a Spark. So Hadoop and Spark given by which company? There's a company called Apache company which is going to be giving. So this is released in year 2003, right? I think this is released in year 2006. Clear? This will be in 1990s and 1970s and 1960s. The files are there. Clear? And completely structured data, completely here structured, as we know, semi-structured and unstructured data, and speed in which the data comes also, there is no problem at all. So these are small data. This is what is called big data. Clear? So any kind of a data, variety of data it can store, and volume of data and the velocity of the data, it is going to be giving you three ways: variety, structured, unstructured, semi-structured data I can store and I can process. And velocity means any speed, every month 1 million data, or every minute 1 million data also I can handle. Any volume, any speed in which data comes, and that is what is called the three V's people will be talking about. That is a solution has been given by Hadoop and Apache Spark. But the problem with the Apache Hadoop is it is going to be storing large amount of data into the disks. Okay, let me talk about these three ways. Big data, it is purest form of big data is used any kind of a data. It doesn't matter. So describe the massive volume of both structured and unstructured semi-structured data that is large. It is difficult to process using traditional techniques. One is storing, the second one is called processing. Two things you need to understand. Clear? So big data is just like what it sounds like, a whole lot of data, right? Now, volume, that is what I told you, right? Volume, variety, and velocity. Volume means petabyte, zettabyte, yottabyte of data, different sources, structured, semi-structured, unstructured. Velocity means speed in which every month you get 1 million rows or 1 billion rows, or every minute you're getting 1 billion data. Any speed or any time, doesn't matter, speed in which data comes. So any kind of a data we're going to be storing, big data. Big data name given by Google company, but you need to have a software. What are the softwares that we are going to be using today? We are going to be using Hadoop, right? Given by Apache Software Foundation. It will be free software. Now, Hadoop can do two things. It can store the data. Step number one, it has to store the data. Step number two, which has to process the data. It is released in year 2005 or 3. I don't know. I don't remember the year exactly, but you can have like that. So Hadoop has to store the data, process the data. For storing purpose, Hadoop has a Hadoop distributed file system. There is a specialized storing mechanism is available in Hadoop. Hadoop distributed file system. It is going to be distributing the data, storing the data across the machines. It's going to be creating a cluster and storing the data. I will be able to talk about cluster and everything later. And for the processing the data, it was using a map reduce program. Okay, map reduce program, which is a completely Java based program. Okay. Hadoop was storing a big data. It can store the big data with the help of what? As we told, it is gone. Okay, let me just write it here. So, Hadoop is going to be storing the data. Okay. For the storing the data, it is going to be creating what? Hadoop distributed file system. And Hadoop also going to be processing data. Two things I told you. Any system is two things, storing and processing. Clear? Processing means computing. So who's going to be computing here? Hadoop. How? It is going to be having a algorithm or a application called MapReduce, which is completely Java based program. So if it is a data, you can also implement SQL that is there, but a more Java based program. So HDFS is going to be storing the data here, and it is going to be storing data into hard disk. Okay. So Hadoop is introduced Apache by Apache Spark in year 2003. The thing was it is going to be doing two, core components. So what are the components? HDFS, Hadoop distributed file system to store your data. You can store unlimited data, right? The second one is called, it is going to be storing, it is going to be processing with the help of a map reduce algorithm. It is developed using in Java, not SQL. It's purely Java program. So the problem is that if you store any data into the hard disk, it will be slow. And a Java program means it will be complex to learn and implement it. Java program is not so easy, right? Learning Java will take 2 years. So Hadoop was telling, hey, you store all the data in the Hadoop, any limited, any size data you give it to me, I will store in the HDFS Hadoop distributed file system. But Hadoop is storing all the data into the computer hard disk. When you store any data into the hard disk, it will be slower, right? So hard disk will be slower, but permanently it will be stored, right? But processing data, Hadoop, HDFS, it is given one application called MapReduce. MapReduce is a completely Java-based program. You need to install. If you wanted to install Hadoop, you know what you need to install? Step number one, operating system. That is OS, Windows 11, Windows 10. Step number two, you need to install JVM. Java, you have to install. Java virtual machine or Java software, Java 9, Java 10, Java 11, you need to install. On top of that, you need to install Hadoop. Clear? Hadoop you need to download from Apache organization because Hadoop is a free software. Java is not free. Java software, you need to buy it. Hadoop, you can install it for free. So operating system, hardware you need to buy, OS you need to buy, Java you need to buy. Hadoop is free. So you need to buy, and without Java, Hadoop cannot run because Hadoop MapReduce system is completely developed using a JVM. What is a JVM? Java Virtual Machines. Because of that, many community folks are told it is a big data, and storing this big data in the disk, because of that, it has become too slow. That is the biggest complaint the community has given to Apache. Who developed, who released this? It is by Apache Software Foundation. This is the compliance feedback went into. So big data fine, but you're storing into the disk and it's too slow and too complex to write the Java code. These two negative feedback has gone. This is the negative feedback went. Clear? Immediately Apache Software Foundation, these people done one more R&D, then they have released what is called Apache Spark. Okay, in year 2006, I think. Clear? The same company, it is also free software. Both of them are free only, right? It is completely free software, and even this is also free software today. Clear? Free software today, it got released. Now in this also they have implemented all these things. You can store the data. You can implement the data. Now they are not storing the data into the disk. Now they are storing the data into the RAM. Clear? Apache Spark is storing the data into the RAM. Because of that, it became faster. How much faster? It is 100 times faster than earlier. Clear? It was not storing anything into the disk. It is everything is going to be stored in the RAM 100 times faster, and Hadoop, it was a processing, right? Now Spark, let us talk about now. Spark or Apache Spark, whatever you say. Apache Spark, or you can say simply Spark. Okay, so simply people will be calling this as Spark, and they have given process. Map reduce is gone. They have given a complete one more language. The language is called Scala. Okay, this is a very very easy language. Now everybody is happy. So two things they have modified. One is called Apache Spark is released free software. Storing data earlier, HDFS was used. It is a disk based. Now completely it has been changed. Now storing data into the RAM. Earlier, for the map reduce algorithm processing, we need to write a lot of Java code. Now Java is gone. They have implemented Apache Spark with a language called Scala. Scala is easy language. Now we have a lot many easy languages. Now either you can use Scala, or many IT community asked, hey, why only Scala? Can't we use Python? Python is easiest language. Then they said Python also you can use. Anyhow, to deal with the data, SQL can be used anyhow. Java, earlier it was there, Java. Any language you can use, you will be able to process the data. That is the reason it became so popular today. Clear? So Apache Spark with Scala. What is a Scala? Scala is the language. Clear? Very, very small amount of code when you write, you will be able to, get the data analytics. See, end of the day, processing means what? Any kind of a processing aggregation you would like to do. See, processing means what normally we do. Processing means either you may clean the data, that is also processing, right? Transform data, you change the data, or this is also processing, or you aggregate the data. Aggregate means tell me month wise sales, right? So you're aggregating the data, grouping the data, all of them are called the processing. So processing means what are the things? Data cleaning is one, that is also processing. For example, I have misspelled data, billions of misspelled data, I have it. I have to replace all the values. Wherever Hyderabad wrong spelling is there, I have to correct it. It is not going to be doing anything unless cleaning the data, right? So transformations, right? So when you have a large amount of data, you can write the coding Scala, you can write coding in Python, either for the cleaning purpose, cleaning or the transformation. Earlier, if you wanted to clean large amount of data, we may use ADF, Azure Data Factory, where with the help of a transformations, we will be able to clean the data. But the problem with ADF, Azure Data Factory, was you have no coding support, right? No coding, simply drag and drop something, and it cannot work with a large amount of data, right? So ADF also transformations can be used. Those are no coding, right? Only predefined transformation. I wanted to write a code and clean the data. That is where ADF will fail. Clear? ADF can extract the data, load the data. That is done. So got the data loaded. After that, I would like to clean the data. Cleaning purpose, I have a predefined data flow activities there or transformations. But I would like to create a complex transformation means ADF will fail. So what normally we do? We use ADF to get the data and load the data. So that is what we do. So if you know ADF, I'm talking about ADF. What it does, it will get any kind of a data. It will get the data from the source. Simply, you dump it to some target. What is the target we use? We use data lake or we use a blob, right? So we are going to be dumping the data here, data lake or the blob. All the data will come here. So what normally we do when you have a large amount of data and if you want to clean the data, the better we can use Apache Spark. So this Apache Spark, right, code you can write, go to here and you will be able to get the data. It has perform ETL operations. It simply got the data and data is available in data lake or the blob. So what you do, it is uncleaned data, right? And this data you're going to be cleaning, and this application is going to be again taking the data from your cleaning and dumping the data from to the next version. Next one will be clean data. So, or ready to use data. So you have it may be a silver layer, right? This may be bronze layer. This may be gold or a diamond layer. You create three folders. Okay. One is a source data. This is what is called cleaning data. Then gold means ready to use data. Like that, we're going to be getting the data, dumping the data. Then we'll take Apache Spark to clean the data because we'll be writing the coding and cleaning the data. Then we use Apache Spark to aggregate the data and we'll keep it here. So all of them can be used by the Power BI developer to see how the visualizations can be done. So we are going to be getting the data with the help of ADF, and we're going to be dumping the data here. And with the help of Apache Spark, we are going to be cleaning and we are going to be aggregating the data also. Aggregating means a group by things. So what we do, we're going to be getting a lot of CSV files or a lot of Excel files we're going to be creating, or anything we're going to be creating. We are going to be, putting them into gold layer. So inside that, what normally we have, for example, I have 147 billion population data. I have it. Very big amount of data. I clean lot of duplicate data. This one. So bronze layer, silver layer to bronze layer cleaning is happened. After that, I wanted to show the reports in Power BI. I cannot give 147 rows, 147 crore data directly to the cleaning it, giving it. I need to aggregate. What is that aggregation I would like to do? I wanted to say state-wise number of people. So that is aggregation. What is state-wise counting operation? Who's going to be doing? So Power BI cannot take so much of a data and do the calculations and everything, charts. So what normally do? I go to Apache Spark. I say, hey, you aggregate the data, grouping by state, and tell me the number of population. Or it will take that data and grouping it, aggregating it, counting operation. Or I want to know income level of each and every individual. So I would like to take the data, aggregate the data. Or I wanted to know how many males are there, how many females are there. So whatever you wanted to have, aggregations also can be done by Apache Spark. So after that, the result output will be kept in the CSV file, or maybe in Azure SQL, maybe in something else, so that Power BI developer will create a visualizations, and end user can see these reports. Like that, we are going to be dumping the data from source to, course, from silver to bronze to, we are going to be having the gold layers. This is what is called medallion architecture. I'll be able to talk about this architecture later. Medallion architecture. Okay, you create a different folders, right? ADF is going to be getting the data. That's it. It is a lorry transport service. So what you do, you go to the farm, get the raw lorry, go to farmer, collect all the tomatoes or the potatoes to this, and after that, what you do, you're going to be dumping into a factory. In the factory, step number one, you're going to be cleaning the data. So ADF is going to be bringing all the data from the source applications, maybe Python, maybe on-premises SQL, maybe file, maybe getting the data from FTP. It may be getting data and dumping into Azure Data Lake or Azure Blob. Step number one. So ADF work is gone. It is simply performing ETL operations, extracting the data. It is not transforming, simply loading. ADF work is gone. Then step number two, Apache Spark code you're going to be writing for doing two things. One is called, you're going to be cleaning the data, because ready-made transformations cannot be implemented because ADF has some transformation for the cleaning purpose. Complex operations, if you wanted to do, ADF will fail. So that is when we need to write your own code. Code can be written with the help of a SQL, not SQL, with the help of a Scala or a Python or Java. By default, we may use a Scala or a Python, because Python I'm asking you to learn. Apache Spark with the Python code we write, we clean the data. Step number one, clean the data. After that, we're going to be pushing aggregations. After cleaning it, I wanted to know city-wise sales. You're going to be creating one aggregation. State-wise sales, one more aggregation. Year-wise sales, one more aggregation. Right? I wanted to have brand-wise sales, if the brand data, or if it is a year-wise data, a lot of aggregations, the code you're going to be writing in the Python, and the outputs are going to be dumping into one more Excel files or CSV files. You're going to be having uh, 25 states we have in India. So 25 rows will go. So source data is 147 crore data, but in the gold layer, you have very small set of a data. That data can be taken by the Power BI. It will show you in the visualizations. End of the day, gold layer will have only a limited, brand wise sales. 10 brands, we have 10 rows. 25 states, we have 25 rows. Years, 10 years data, you have 10 rows. So very small amount of data will be there in the gold, but source data will be in billions and trillions of data. Clear? So the data from the gold layer will be taken by the Power BI or reporting applications. So those people are going to be creating a charts and giving it to the end users. End of the day, visualizations will be there, or AI team is going to be using your data. They may use raw data, or they may use any other data. Whoever needs what kind of a data, we have uncleaned data, we have a cleaned data, we have aggregated data also. Whatever you would like to have, that kind of a data we can supply. So this kind of a folder creation, silver folder, then we create a bronze or gold, diamond folders. We create them. So this architecture is called as medallion architecture. Clear? Is Spark one is called storing the data in the RAM, and the processing. Processing two things: the cleaning of data, or aggregating the data and grouping the data, and performing some min aggregations, all of them. So this is what we're going to be doing with the help of your ADB. So by default, what language? Scala. But what normally we use? Python. Okay. So this is what you have to know, the purpose of Apache Spark. Okay, these are the things that you need to know. So with the help of Apache Spark, structured data, relational data, unstructured data, but also streaming data, your big data will streaming data means every minute continuous data you're getting it. For example, live cricket match data or weather forecasting data, Sensex share market data. Every minute the data will change. That kind of a data, your SQL, your data warehousing cannot handle. Streaming data, your data warehousing cannot handle. That is also big disadvantage of data warehouse. But your Apache Spark can handle big data or structured data, unstructured data, relational data, that means SQL data, and streaming data also Apache Spark can handle. But your SQL or data warehousing cannot handle streaming data. Okay, so when you have a big data, raw data, then making it to meaningful, then knowledge, then wisdom. So all these things can be applied on this data. Two applications are going to be working: AI and BI. Right. AI and BA is going to be working, whether the data may be there in Excel or SQL, or maybe data warehouse, or maybe in the on Hadoop, or maybe in the Apache Spark. These two applications are going to be working with this data: Excel, SQL, data warehousing, and Hadoop. So in both applications are going to be working with this data. So BI means Power BI we're going to be using. Here we are going to be using AI and ML applications are going to be running. Clear? That is what you got to understand. Chalo guys, we will be able to see the data bricks. What is the data bricks now? Data bricks is a completely a software that is going to be working with the help of this. Databricks is a Spark, but with a nice GUI on top of many automated, easy to use features are available. Databricks handle creation, a configuration of server cluster connections, blah blah blah, an interface for the Python, Scala, SQL. Databricks available to the cloud. So what is the Databricks? That is the question you should ask me now. So Databricks is a middleman or the agent. So what is going to be happening? The question: who is Databricks or what is Databricks? Databricks is going to be an agent. So what it does? So as I told you, you need to have software and hardware, right? So we have now Azure is going to be giving you software and hardware for rental. Or you can go AWS and you can get hardware software for rental. Or you can get Google Cloud, you can get hardware software for rental, or you can go on premises hardware and software. So now I wanted to have, what do you say, Apache Spark. I need to buy some machines and I need to install it. For example, I may buying two machines, or I may be getting two machines from Azure, or I may be getting three computers or two computers. However, computers you can take it. I may be buying means own computers. Renting means it'll cheaper. So you may be buying four machines here. So if you go to Azure, you got two machines. If you go to AWS, maybe getting three machines, four machines. But somebody has to set up the software, right? Who's going to be doing that? So Databricks is the company at the middleman. This guy is going to be going and setting up all the Apache Spark here, configuring everything here. Apache Spark, it is going to be installing. So here also we can install Apache Spark. Here also we can go and use Apache Spark. So who's Databricks? Databricks is an agent. So for example, this is me, this is you. Okay, you are going to be having a marriage party. What you do? You have a function hall one. You have a function hall two. You have a function hall 3. So what you do, you directly go and book a function hall, either this function hall, this function hall, this function hall. You can book a function hall. After that, you have to talk to the function hall manager for the catering, food, decoration, video shoot, audio shoot, fun games, return gifts, everything you need to talk to them. If the functional manager says, "Sir, we don't deal with anything," you need to go and check. So you need to go and look for a cameraman. You have to go out and look for the catering. You need to go and look for the decoration. But there is an agent. One agent is there. The agent name is called event manager. Event management company we have. So what you do, instead of you going to the functional directly, you go to the event management company. This is you. The event management company is called Databricks. Okay, this is a middleman broker. So you talk, I need this kind of a configuration. I need these many missions. I need to have Apache Spark there. I need to have nice, rich and feel UI. I need not, I should have a proper UI. So I would like to write the code. I need to have like this. Means everything you say, Databricks is going to be going to one of the function hall and booking, because we have thousands of function halls in the city. So it may Databricks may go to Azure, may set up Apache Spark there, then it will become Azure Databricks. If the Databricks is going here and setting up a function here, it will become AWS Databricks. So Databricks means it is an agent. Agent is going to be doing all the configurations. What are the things you need? You need to have hardware, and Apache Spark has to be installed. And to write the code, you need to have proper UI. Everything will be given by you. So you always go to Databricks and try to give the code, or Databricks will be giving, but Databricks may be running a separate setup either here, or maybe here, or maybe here. So what is the advantage? Databricks is a middleman agent. Clear? Databricks is a middleman or agent. He will be able to take care of a lot of things. Best UI he will give you, because Apache Spark does not have a best UI, and you cannot work directly with Apache Spark. Lot of issues. So if somebody comes, you talk to me, I will take care of many things. So you write all the coding where in the Databricks. Databricks is an independent broker or independent software which is going to be either creating your cluster or machines either in the Azure or in the AWS or in the GCP. So when you say Azure, you will become Azure Databricks. So when you say I would like to have my machines in AWS, means you can go to AWS and get the Databricks installed. Databricks means what? It is going to be installing Apache Spark only in couple of machines. How many machines you need? One machine, two machine, three machines. Like that, it can do the setup. So code, where will you write? You simply write the code in the Databricks only. Databricks converting all the code into the Apache Spark code, and it's going to be getting executed. We may write Scala code, Python code, Java code, but we are only talking to the Databricks. Databricks internally doing the setup here. So this is what you got to understand. So who created Data Bricks? Data Bricks is created by Dr. Ali. So God, he is the guy. So he has given you simplified UA, user interface. Clear? So talking to the Apache Spark and configuring Apache Spark will be difficult for anybody. So he's made it simplified. So you come to event management. I will take care of everything. Food catering, camera, decoration, everything I will take care. Why you need to go there and book everything? End of the day, you can go to Databricks. Databricks is going to be doing everything. It will give you simplified UA, and they will do the configurations for you. So that is the reason we can get on premises also. So Databricks can be used on your on premises computers also. Clear? Or cloud computations, any cloud. So this is what you got to understand. Am I clear? So Azure first party service tightly integrated with the related Azure services, blah blah blah. Analytics data lake house is the good architecture that we're going to be talking about it. Azure Data Bricks is the broker software, or you can say it is going to be installing, okay, all the necessary softwares in given cloud, maybe Azure, maybe AWS, maybe Google, or if you have own machines on premises also, you can run your Azure Databricks. That is what you got to understand. And Apache Spark especially has a lot of libraries: streaming library, machine learning library, graphics library, lot of coding, Java code, Scala, Python, SQL, or any coding you can run in the Apache Spark. Apache Spark means today Databricks only we're talking about. Okay, na? So that is what you got to understand. Streaming data can be implemented. Lot of other things we'll talk about later. So Databricks is good for large scale data, streaming data, batch data. Batch data means it is OLAP data or data warehousing data, timestamp data, history data, graph data, pattern data. Lot of things you can use within your Apache Spark. Spark means Databricks only. Okay, na? So data lakehouse we will talk about later. So these are the things that you have to know about Databricks. Clear? What is a Databricks if you wanted to know? So Databricks, you can see here 2005, 2006, 2009, 11, 12, 12 you got Databricks. It is a Spark. Databricks is a Spark, but with a nice GUI. Databricks handle creation and configuration of server cluster connections to various systems, programming interface like Python, Scala, SQL, blah, blah, blah. Non-users to say lot of things. Databricks is available as a cloud service on Microsoft Azure, Amazon AWS, or Google Cloud, plus a free community edition also. Databricks, you can use it. Clear? So Databricks is released in 2012 or 2013. Clear? So that is what you need to understand. So tomorrow I'll talk about how Spark can take large amount of data. Okay, Spark is a single machine, multiple machines. What is a cluster? All these things I will be able to talk about in tomorrow's class. Hope you're able to enjoy what is the purpose of Azure Data Bricks. Azure Data Bricks is nothing but your Apache Spark only. Apache Spark, earlier called as Apache Hadoop, right? It is going to be storing data and the processing the data. Storing means you can store any kind of data, structured, unstructured, semi-structured data. Processing means you can clean the data, that is also processing. You can aggregate the data, perform some kind of an grouping clause, that is also processing. So cleaning, transformations, and grouping, and getting a lot of aggregations, that is also kind of a processing. Clear? All of them can be done with the help of your ADB. ADF is simply a transport service. Get the data, load the data. Cleaning, somewhat cleaning also can be done, but with the help of predefined transformations. If you wanted to write the code, ADF cannot be used. So after that, when the data is ready, if you want to clean the data, aggregate the data, we can use ADB to clean the data using a coding, Python or Scala coding, Java coding, we can write. we can group and aggregate the data, give it to the next people. Next means your AI guys, BI guys can take the data, they will be able to work with the data. AI guys are going to be predicting the data, BI guys are going to be, understanding the past. So your Apache Spark data. So today Chat GPT is Apache Spark only. Chat GPT is AI application, but data Chat GPT is getting from where? From the Apache Spark or Data Bricks data it is. Clear? It may be structured, unstructured, semi-structured data. That is what you got to understand. Chat GPT data, it is getting thousands of Himalayas data it is bringing. Think like that. Apache Spark is not a small size data it is going to be storing. It is going to be getting thousands of Himalayas data. That is how you need to think. Petabyte, zettabyte of data. Normal companies cannot maintain that kind of a data, right? So companies like Google, Elon Musk companies, Meta, Microsoft, Facebook, these kind of companies can run Chat GPT Copilot applications because Apache Spark is not running in a single machine now. We are going to be getting lot many machines. Apache Spark is going to be running into clusters. Tomorrow I'll talk about what is a cluster and what is a cluster architecture. We'll talk about all of them in tomorrow's class. Hope you have enjoyed it. Any questions?